Hello everyone. Today we are looking at LeetCode problem number 112, path sum. In this problem we are given a binary tree and an integer target sum, and we should check if the binary tree contains a path which starts at the root, goes all the way down to leaf, such that the sum of all the values on that path equal the integer target sum. In this example here, the target sum is 22, and if we go from the root along this blue marked path, the total sum is 5 plus 4 plus 11 plus 2, which is 22. And how are we going to solve this problem? In principle, trees are recursive data structures, so often it makes sense to use a recursive solution. And in this case, we are doing some kind of search, so often we can use a top-down approach for finding this kind of path. Let's look at a few examples. So, we want to write a recursive function called has path sum, and it should take a tree, or let's say a pointer to the root, and it should take an integer target sum. And since we want to write a recursive function, it makes sense to first think about the base cases. So, first case, root is null. So actually we don't have a tree, the tree is empty. And this case is already defined in the problem statement, or to be more precise in the example. In this case, we should always say that there's no path sum, because there's no path. The second base case happens when our tree is actually a leaf. So that means that root.left and root.right are null, and in that case we have a leaf, because we have, okay, let's say the root is not null because we already handled that in case 1. So when do we have the target sum in that case? Well, our tree looks like this, and in here is a value, and left is null and right is null. So the only way to make the root path is to, well, start and end at the root. So we can return whether the value is identical to the target sum. If yes, then we found such a path. If not, then there can be no such path. Now, let's look at the complex case where we have here our root node, and let's say in it some value, let's say 5. And now we have a left subtree and a right subtree, and our node is not a leaf, so either the left is not empty or the right is not empty. It can be that one of them is empty, but not both of them. And well, we also have a target. So let's say, for example, that our target sum is 22. Now, what can we do? Well, we know that our path must start in the root. So we already know for sure that we have 5 as part of our path. So we can already subtract 5 from our target sum. 22 minus 5 is 17. And we now know that we need to find a remaining path to a leaf with a total sum of 17 in one of the subtrees. So either we can go inside the left subtree and inside here find a path from the root of the left subtree down to a leaf of the left subtree, and this path in here must have a length 17. Or we can go in the right subtree and then we must find a path from the root of the right subtree to a leaf of the right subtree, and this path must also have a length of 17. If we can do that in either of the subtrees, then we have found a total path starting at this 5 going to a leaf. If we cannot do it in either of the subtrees, then there's no solution. Okay, let's go to the code. So here's the code of our solution, and we handle the 3 cases that we just talked about. The case 1 is that the tree is empty. In this case, we just check if the root is null and we can return false. Now the second case. The root is actually a leaf node. Well, for that to check, we need to check if both the left and the right subtree are null. In this case, we are a leaf, and we need to check if the value in the leaf equals the target sum. Now the third case, which is the interesting one. Here, first we subtract from our target sum the value of the root, and next we check both the left subtree and the right subtree. And we do this using recursive calls. In the first recursive call, we check the left subtree and we look for our updated value where we already subtracted the root of the original tree. In the second recursive call, we do the same, but for the right subtree, also with the updated value. Finally, we use the OR operator to combine the results, because if there's a solution in the left subtree or in the right subtree, then we have also found a solution for the whole tree. And let's run it. It's accepted. So that's the solution to this problem. If you liked the video, please leave a like, subscribe to the channel, and I see you in the next one.